Hey guys, what's up? Welcome back to our series on a choice-based approach to microeconomics. In this video, we're going to talk about preference relations and the regularity assumptions. Let's go. So we note that a preference relation is technically a binary relation on a set of alternatives X, which is our commodity space, which allows for comparison between any two bundles, little x and little y, inside this commodity space. In short, a binary relation is a concept in discrete math used to demonstrate how objects are related to each other. In general, we say little x is this little symbol over here in terms of y, means x is weakly preferred to y. This embodies two relations, this symbol here. It embodies the strict relation, meaning x is strictly preferred to y for some elements, and it embodies the indifference relation where we have x is indifferent to y. What this means is if we go and we have L many commodities and there are two bundles, X being equal to 1, 1, 1, 1, 1, 1, 1, and for the last element we just have 1 there at the end, and Y being 1, 1, 1, 1, 1, 1, 1, 1, 1, all the way up to the nth element, but at the nth element we have 0. We say X is strictly preferred to Y for that one element. If our individual is indifferent regarding the last element, we go and say X is weakly preferred to Y. Now, let's go and talk about what exactly rational preferences are. And you hear this a lot when you're going and talking about economic agents in general, but really rationality is just two things. We say a preference relation is rational if preferences are complete, meaning any two bundles could be compared, and preferences are transitive. This just means that if A is preferred to B and B is preferred to C, that means A is preferred to C, right? This means our auxiliary comparison holds up to direct comparison. That's how I would go and put it. Mathematically, we write these two assumptions as follows. For X and Y in our commodity space, we have X is weakly preferred to Y, or Y is being weakly preferred to X, or both. This doesn't limit anything. And for X, Y, and Z being in our commodity space, we embody transitivity by if X is weakly preferred to Y and Y is weakly preferred to Z, then X is weakly preferred to Z. So this is the point of our auxiliary comparison holds up to direct comparison here. So from this weak preference relation, we can derive two properties in terms of relations. We can go and talk about our strict preference relation, where we say X is strictly preferred to Y for all X and Y in our commodity space. We have X is at least as good as Y, but Y is not as good as X here. And for our indifference relation, we say X is indifferent for Y for all X, Y in our commodity space. We have X is weakly preferred to Y, and Y is weakly preferred to X. So that's what it means in terms of having a strict preference relation and a indifference relation. It's just a matter of saying what we mean and what that implies there. We also have three regularity assumptions, and they don't have to be in for each other. We have this concept of local non-satiation, and mathematically that means is that if X is a consumption set or a commodity space, for any X in our commodity state and every value epsilon greater than 0, right? This is just a very, very, very small number. There exists some other bundle Y in our commodity space, such as the distance between these two bundles will be less than or equal to epsilon, and Y is preferred to X. So what this means practically is that there will always be some bundle which is desirable, but which is just out of your reach. Monotonicity here, right, that goes and implies a sort of direction in terms of your goods. So it says that if the amount of goods in all your categories in bundle Y is strictly greater than that of X, meaning every single good there's more of, right, then Y here is preferred to X. And for strict monotonicity, right, some people get confused with this, we say that if there is only one element in Y that is greater than X, right, we have Y being strictly preferred to X. So we only have to have one good there. And there's a little point here, which I'm going to go and put down on the slide, where we go and we have this little causal chain, strict monotonicity, right? That implies just regular monotonicity, or some people call that weak monotonicity, which implies this concept of local non-satiation. So it goes this way, but local non-satiation doesn't imply monotonicity and strict monotonicity as well. So let's discuss this concept of local non-satiation, monotonicity, and strict monotonicity in a little bit more detail. Let's say we have some bundle over here, right? Just on this graph right here. What local non-satiation implies is that there is some ball around here, right, of, say, epsilon distance here, where there exists some desirable bundle. Now, this bundle could be in this direction, in that direction, in that direction, or that direction. It doesn't really matter at all, really. It just matters that there is a bundle that is more desirable than this one in any sort of direction. Now, what monotonicity goes and says is that it says really that more is preferred to less, or really strictly more is preferred to less. So what really we have here is that we have these four quadrants here. So we can say for certain that this is not preferred at all. We don't know about these areas here because this isn't what we can say with regards to monotonicity. But we can say that the area of desirability is in this area here. Now, what regular monotonicity says that strict monotonicity does not is that we can't go and think about along this line, right? We can't think of what's along this line, meaning that if you hold x1 constant and only vary x2, or say x2 constant and only vary x1. In the context of strict monotonicity, if we go up in this area, right? If we go and increase any bundle anywhere or any amount of any good, right? We're going to have that bundle being preferred to this original bundle here. So that's just a little bit of an informal conversation on what these things are. Now, even though this is a video series on a choice-based approach to microeconomics, some things should be said about utility functions. In a world where our preferences are rational and continuous, we have the case where x being weakly preferred to y implies our utility function evaluated at bundle x is greater than or equal to the utility function evaluated at y. We say that u, right, our utility function, is quasi-concave if it embodies well-behaved preferences. This is often referred to on the intermediate level of averages are preferred to extremes, but this is just technical lingo here. So what this means practically is that this function is quasi-concave, but its level curves are convex. Now, convex just means if you go and you take any 2 points here, right, and join that line here, this point here will be above that line there, right? And that's in terms of this weighted average sort of property here. So this is our video series on our choice-based approach to microeconomics, our second part. In the next video, we're going to be talking a little bit about work in this context and be discussing the ideas of budgets without necessarily talking about prices in that context. See you in the next video. Take care.